Okay, so last but not least, right? So big idea here. What about vertical and horizontal asymptotes? Well, for vertical asymptotes, it actually comes back to the domain. We're looking for when I divide by 0. If we have a vertical asymptote, that's typically where that ends up happening. So in this case, the domain was everything. So this means no vertical asymptotes. This guy had a domain of everything, so no vertical asymptotes. This guy had a domain of everything, so no vertical asymptotes. And then it was in part D where we realized that a division by 0 is possible, right? So in an earlier video, we found that the domain, we had to throw 4 out. So x cannot equal to 4. So the vertical asymptote will occur at x equals to 4. So if we were to graph this function, if I was to do a quick sketch at x equals to 4, I would expect to see a vertical asymptote at that location. So there's basically how you find a vertical asymptote. It's very closely related domain, and if you have a division by 0, and assuming some other things aren't happening, which holes and all that, which I'm not going to worry about here, right? It's just going to be simply division by 0 pretty much gets the job done. So the next one, we found that, again, related to domain, all right, we found that the value that didn't work was x cannot be equal to -4/3. So that basically means x is not equal to 4/3. So where's our vertical asymptote? Exactly at that location. So again, if we were to graph this function, here's -1 and -2 at roughly -4/3 right there. There would be a vertical asymptote. For part C, when we did that, we found that x could not be equal to plus or minus 3. Right? Those are the two bad values for that. So where's my vertical asymptotes? At those two values. So again, if we were to graph this at 3 and -3, we would have vertical asymptotes. Letter G, earlier we found that the domain, right, we don't want x to be -1 or 2. So that basically means my vertical asymptotes, right, are going to occur at those two locations. And again, if we were to graph this at -1 and at +2, we would have vertical asymptotes for that graph. All right, and then last but not least, these square root functions, there was no division by 0. The domain's restricted, right? In this case, the domain was 0 to infinity, and over here we got -2 to infinity, but there is no division by 0. So since there is no division by 0, there are no vertical asymptotes. And here there's no vertical asymptotes. So really, to find a vertical asymptote, it's all about your domain where the red flag of division by 0 occurs. You find where the division by 0 occurs, you basically have gotten or have found your vertical asymptote. And like I said, hopefully in a very strong college algebra class, you looked at some situations where there were holes, but we're not going to see that in this class, so we don't have to worry about holes as far as we're concerned. You can worry more about that in calculus. So there's your vertical asymptotes, part D. What about horizontal ones? Well, what happens in a horizontal asymptote is that as x gets big, and in a graph, right, there's two ways that the inputs can get big: positive infinity and negative infinity, right? And so as x gets big, it turns out that the outputs go to some limiting value, and that's what a horizontal asymptote is. And to make a long story short, right, it turns out that right now the only thing that has a horizontal asymptote is when we're dealing with what's called a rational function, where I have a polynomial divided by a polynomial. So this is not a rational function, this is not a rational function, this is not 1, this isn't 1, and this isn't 1. So there's no horizontal asymptote, no horizontal asymptote, no horizontal asymptote, no horizontal asymptote, no horizontal asymptote. So that makes that easy. However, for the 4 that remain, right, what we have, right, is we have a poly over a poly, a poly over a poly, a poly over a poly, and a poly over a poly. So we do actually have a horizontal asymptote in this case, or in some cases it might even be a slant, but we're not going to worry about those here. So how do I find the horizontal asymptote? Well, remember, my inputs are getting big, right? So as x gets big, larger and larger and larger, right? 1,000, 10,000, 100 million, right? This denominator is getting very large. So the top is stuck at 4, and the bottom is getting larger and larger and larger. So what's going to happen is the function value is going to get smaller and smaller and smaller. So the horizontal asymptote is y equals to 0. So if we were to graph this, I already kind of have a sketch of this graph. We already know where the vertical asymptote is, so the horizontal asymptote is basically the x-axis, y equals to 0. So there's a really quick sketch of what this function looks like based off of the two asymptotes that we have. The vertical asymptote occurring at 4 and the horizontal asymptote occurring at y equals to 0. And essentially what we're looking for is the dominating terms. Like in the next one, right, we have x in the upstairs and the downstairs. So as x gets large, subtracting 2 and adding 4 is going to be irrelevant. So we're basically looking at 3x over x, which leaves us a limiting value of 1/3. So the horizontal asymptote in this case will be y equals to 1/3. So if we were to graph this, this is going to be kind of 1/3, probably about there, right? Based off of this information, right, my graph probably looks like so. All right, sorry for it looking so messy, but hopefully you're recalling some ideas from a college algebra. Here, again, as x gets large, adding 5 and subtracting 9 is not going to be a big deal. There's my dominating terms. So x over x squared behaves a lot like 1 over x. And of course, as x gets large, right, this is going to taper on towards 0. So my horizontal asymptote in this case is y equals to 0. So this has two vertical asymptotes, and then this will serve as the horizontal asymptote. So somewhere out here, the graph's going to be doing that. And of course, we'd have to figure out, is it this way, is it that way, this way or that way? We'd actually have to look at some more details to get that, but I'm not going to worry about too much about that. We're just looking at horizontal asymptotes. And then last but not least, right, again, we're looking at what predominantly is going to be our big major factors, right? So these are not going to be, these are going to not be a factor when x gets big, and pretty soon x squared, right, is going to dominate just x. So the dominating terms here are x squared over x squared, which leads to 1. So the horizontal asymptote in this case is y equals 1. And so there's basically that. And again, we'll have to do some point plotting. Are we here? Are we here? Are we here? Are we there? Which one it is, we don't know without some other detail in the graph, but I definitely can basically get a feel for what's going to have happening with the shape. It'll slowly taper off to y equals 1 as we move to infinity. All right, so that took 3 videos, but hopefully it was a very good formal review of graphing and domains and intercepts and asymptotes to get us ready for some things that are coming. All right, and so I'll do that in some more videos.